actually in the screen?
Yep, you're right in the bullseye middle. And it's recording. I don't like it.
Why?
Because you're not smiling.
Well, I'm not ready to shoot yet. All right, everyone. Welcome back. I'm just going to say something here real quick before we get started on our video. If you see my shirt here, I wore this today to honor not only all of our veterans, both active duty and retired, but our son is currently serving in the Navy as well. He is a EMN, Electrician's Mate Nuclear, and will be deploying to one of the carriers in whatever ocean they decide to send him to fleet. Should be the middle of March next year. So that he is an Electrician's Mate Nuclear, and he's Petty Officer 3rd Class, and we are extremely proud of his career selection and that he has given that service and that sacrifice for me and for you and for everyone around the world to keep us safer. So thank you to everyone who has served or is still serving. We definitely appreciate that. Let that be known. Thank you. Hello again, Frontier Geek fans. Coming back at you with the part 4 here of the wiring and fuse selection series. This, I believe, is probably going to be the last of this series. I'm going to show you a few more things that we can use here to tie into the other 3 videos that I produced earlier, and hopefully wrap this up where you will feel confident enough to try maybe some wiring projects of your own. So let's get started. First of all, I'm going to show you, might be an answer to a question nobody asked, but I'm going to show you some of the kit that I keep around, my stock, so to speak, and I'll show you this nifty little storage unit that I found. And here you can see that I have an array of different electrical parts, including a quick disconnect that I used several of these in the overhead console project, which I believe I covered in another video. If not, I'm going to go back and look at that. Maybe that will be another video. Anyhow, these are extremely handy if you're building harnesses that run throughout the truck. I used actually 2 of these up in the top. Let me take that apart again. Yeah, they don't pop apart real easy, which is a good thing. You don't want them to. So I used 2 of these for the upper console, you know, where you keep your sunglasses at, etc., etc. And so when I put these together, what I did was on the truck side of the harness, I put with one of the connectors this end. The other half of the harness, I should say, I flipped it and put this end. That way, when I go to service it later and I take these apart, it's impossible to plug it back in correctly, because you'll never get 2 of these to mate or 2 of these to mate. So that way, if you do a little bit of diligence when you're assembling your harness, you never have to worry about making a mistake later and blowing some fuses, or if there happen to be electronics tied to it at the other end, you could possibly blow something a lot more expensive and a lot worse. So, little tip. So let me put that back in there. So here you can see I have an abundance of different ring terminals, etc., etc. Won't belabor the point. Close that up. I believe I got this at Home Depot, if I remember correctly, because it has the orange tagging on it, which is their trademark color. Flip over to here and show you all of what's going on this side. And these are basically all of the pieces that go on to units like this. So you've got your push-on terminals here, spades of different sizes, different wire gauges. Some of these are straight. Some of these will, now let me see if I can give you a little bit of a better view there. Here we go. And okay, you can see that this one turns a 90-degree angle. It's called a flag style. And then you have the more common straight style, which can be extremely handy if you're working in a very tight area and you need to have something set up where it can immediately make a sharp turn. So anyway, back to that, not to belabor the points. You've seen what I have in here. Let me close that up. So back to what we were going to talk about as the main body of the video, and that is fuse and load and wire selection. So first of all, you need to know what it is you're working with. So believe it or not, I don't really seem to have that many items that are 12 volt powered that are not already hardwired. So I had to go hunting a little bit to find something to actually use as an example. So here I have my portable air compressor. Yeah, it's a pretty typical one. You know, it's a Chinesium. It's nothing fancy, dual cylinder, came off of, I think, Amazon. Anyway, just using this as a plug-in 12 volt example, right? So let's say that you are going to run a new circuit. You wanted to have this to be able to plug in, let's say in the bed of your truck, which is actually where mine plugs in right now. I do have a dedicated outlet back there, which I had actually showed in another video, how that was constructed and assembled. And so back there is a switch which will turn that on and off, and also a 12 volt power outlet and two 5 volt USB charging outlets, which could be used camping or whatever. You know, if you're sitting around playing a radio, you can plug in a Bluetooth speaker. I mean, you know, the uses for USB power these days are nearly endless. You can charge your cell phone, blah, 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 right? So anyway, so here's where we get started. First, we have to figure out what it is we're trying to connect. So if you look at this here, and you take a look at the tag here, I don't know if you're going to be able to read this, but let me see if I can get it closer to the camera. And if you're noticing that I'm looking to the side, yes, I actually have a monitor now attached to the camera so I can see what I'm actually doing, which has been really helpful. So this has a nameplate rating of 12 volts at 30 amperes. Now, I happen to know in this particular case that that is incorrect, and a lot of these are actually overrated. This says maximum draw 30 amp, and why I know that that's overrated is this runs just fine on the 20 amp circuit, which I have run to the rear of the truck. So let's pretend that I didn't say that. We'll disregard that and we'll go back to doing as we should. So follow my example, not my install, I suppose, right? Okay, so nameplated 30 ampere, so we'll work from that. All right, so now we put that away. We've decided that we're going to mount a socket in the rear of the truck. Now, avoid the tendency, which some people have, of never using one of these, a good quality relay, and B, of not using the correct wire size, and C, of taking one of these guys right here, slapping this on the end of your cable, and just merrily connecting it right to the battery and connecting it over to your load. Will that work? Yes. Yes, it will. For a while, most likely. It might work forever just fine that way, if you never have a short. If you ever have a problem in that circuit, or you overdraw that circuit, you're probably going to melt the wire, possibly set your truck on fire, or other really undesirable type of outcomes. So, you're probably thinking, wow, how do I avoid that? I'm glad you asked. That's the reason we're doing this video. You need to make sure that it has some type of circuit protection. Here's how you do that. Or one way you could do that. There are multiple ways. Go ahead and pop this off. Alright, so this is a multiple fuse block. This can hold up to 6 circuits. As you can see, there are 6 pins on each side. Fuse goes here. Has a plastic cover, which keeps basically protecting the terminals from dirt and possibly water splash, although this is not rated for any kind of actual direct water impingement or submerging, IP65, IP67, etc. So these are best if they're in a protected location, somewhere in the engine bay. If it's pushed well away from the wheel arches or any place where water's really going to intrude, you keep it dry, it'll be okay. Actually, inside the cab is best, but we'll get into that a little bit too as well. All right, so back to where we were. Okay, so we're looking at this. We're saying we have a 30 amp draw. So we go figure out from our wire chart, which I will insert right here. Okay, so now you've gotten a chance to see the wire chart. That wire chart tells you what amperage wire, what gauge wire you're going to require for your amperage. Follow that closely. That is important. You do not want to overdraw your circuit. A wire too big is not going to hurt anything except your wallet. It's going to be a little more expensive because I don't know if you've priced real copper these days, but yeah, it's not pretty. Undersizing a wire, you very well may, back to the condition that we were speaking about earlier, you may have a fire. Definitely want to avoid that. All right, so with our 30 amp draw here, right? So we figured out we're going to place this. We're going to put this on there. We're going to connect it after we've crimped it, which I covered in another video. We're going to go back and we're going to connect it to our multi-circuit, right? Now, you could do this a couple of different ways. You could just have this and this end here, like with those terminals I showed you earlier. You could just connect it into here, and then the load side would come out the other end. It doesn't matter which way this goes. There's no current flow. There's no proper current flow connection for this. It's not handed. It's not like a diode. It doesn't go from positive to negative or anything like that. It completely matters not at all which way this is connected. Just make sure that both of these connections are done correctly. So after you have that connected onto here, right, well, what are you going to do next? Now that you've got your wire sized correctly to figure out where that should be hooked to, well, as I mentioned earlier, you shouldn't go straight to the battery. And you're like, okay, well, if I'm not going straight to the battery, what am I doing in between? I'm glad you asked that question. You're going to put a fuse in here. Probably most of you know that already. It is fairly elementary. And let me go ahead and snap that in. Yeah, these are quite stiff. Yeah, this particular guy does not want to snap in. That's pretty funny. All right, there we go. Okay, well, this is a Chinese fuse block, so it may not be perfectly formed in all of its sockets. We'll let it go at that. But anyway, I believe you're getting the idea here. So that snaps into there. All right, so now you're probably going, well, okay, fuses come in a whole bunch of different types. Yes, they do. They can go anywhere from 1 ampere up to 40 in this type of a style that looks like this. All right, after you get past that, it goes up into 50, 60, 80, 100, 120, etc., etc. You get into much larger fuses. They usually have a body like this. Sometimes they're glass, sometimes they are plastic in a flat package, and they usually have screw terminals on both ends, with those screws mating to a specific holder which is designed for that you mount that down tight by just torquing those screws to the proper torque spec. That's something you want to look at too. They don't need to be over tightened. Another thing always to remember when working with any kind of fastener, watch your torque specs. So that's how you would take care of that situation. So here we've got this, we've got it wired. You're just going to run this, like I said, through here. You would have another piece over here, and then from there you would just string that out, and that would connect to your load. And like I was saying, different size fuses. All right, these happen to be 25s. As I had mentioned, I know that even though that thing is nameplated at 30, it's not really drawing 30. So it would be safe in this particular case to install a 25, which you could do just like I've done here, and run that through. Now you want to make sure that the fuse is never a larger rating than the maximum current carrying capacity of the wire that you chose from the chart. So as I mentioned earlier, the chart's posted. Go back to the chart. The current carrying capacity of each lead is indicated in there for what your expected distance would be, and also your loading. So if you had selected this, say a number 12, you would make sure that the fuse was never rated for higher than the current carrying capacity of a number 12, or 10, or 16, 18, whatever it is you're working with. It's not necessary to make all circuits gigantic. Size them correctly and everything will work out just fine. And that's pretty much really all there is to it. It's not that difficult. So as a quick summary, first you start with your load, figure out your maximum nameplate rating, see where you're going to go from there. Next, you're going to pick out your wire. You're going to go ahead and select that, size it accordingly, and then pick the correct fuse. Make sure the fuse holder is rated at least for the amperage that you're putting in. Most fuse holders are actually pretty heavy duty, although they usually will have a rating on them as well. They will tell you if that's going to be sufficient for the project that you're installing them to. And then after that, the last thing is to select the fuse. Like I said, fuse always needs to be equal or lower than the maximum rated current carrying capacity of your wire. And after that, that's pretty much it. It's actually that simple. As I'd mentioned in one of the earlier videos, people seem to think that wiring is some sort of black magic, that electricity, because you can't directly observe it, you can't just look in the end and go, yeah, I see electrons, wow, neat. They're very scared of it. They would have no problem tearing an engine or a transmission apart. Any kind of really, really difficult, involved project doesn't bother them in the least. Hand them a pile of electrical parts and say, I need you to build something out of this, and they're terrified. They're going to run away screaming, going, no, I can't. Yeah, you can. Really, following all these safety procedures, following what I just detailed here, if you go back and watch the other 3 videos, with all these 4 combined, there's really nothing in a relatively simple project that you're not going to be able to accomplish. If you went back and looked at the walk around video and you saw the relay box that I had built for the truck, which is over on the passenger side near the blower motor, yeah, you'd probably look at that and go, whoa, that has 7 relays in it and a whole bunch of wiring, a whole pile of fuses. Yes, that was pretty complicated. That did require some thought. I've been doing this for a long, long time. I'm 56 years old and I've been doing this since I was a teenager. My father got me started in basic electricity when I was a kid. So I've got a lot of experience to draw on. So don't feel bad if you didn't. If this is your first time through, hey, don't worry about it. It's all good. Don't be that afraid. Take a look. There are many books. Hopefully this video as well is helpful. Try something fairly simple. Get your feet wet. Jump in. Go from there. You never know where it's going to take you. Could become a very good hobby. Till next time, Frontier Geek out.